Hello, my name is Toby Collins and I'm the Director of Research in the Surgical Data Science team in IRCAD, France. On behalf of my co-authors, I'm pleased to present our abstract titled Automation of Skill Assessment in Flexible Endoscopy using AI to Automate Task Completion Timing. Objective skill assessment is an increasingly important part of surgeon training and certification. SAGES has been a leader in this field with programs like the FLS and FES. In flexible endoscopy, virtual simulators are commonly used both for training and assessment with great success. However, they are limited by high cost and they are only available in a small fraction of centers. They also tend to lack physical realism. Mechanical simulators such as the Basic Endoscopic Skills Training Box or BEST box, shown on the right, offer a solution. The BEST box is a cheap clip-on modification of the FLS box. It has 6 endoscopic tasks that focus on fundamental endoscopic skills. It has an objective scoring system based on task completion time and task mistakes, such as dropping a peg during transfer. Scoring is performed by a trained human rater who watches the video, and scores correlate well with gauges. However, an important limitation of all mechanical simulators is the need for human raters. We aim to overcome this limit by creating an artificial intelligence rater. We intend to run this AI software on a low-cost mini PC, such as the one shown from NVIDIA, that can easily sit on any endoscope column or tabletop. The AI rater effectively converts a mechanical simulator to a truly low-cost digitized automatic scoring device for objective self-assessment and potentially high-stakes examination. Our first objective is to automate one of the main scoring parameters, task duration. We have solved this by training an AI system using deep learning that is capable of taking the endoscopic video and automatically recognizing which task is being performed at any given time. We illustrate this with a timeline, where the video is divided into time segments corresponding to each task. The AI system can also automatically recognize when the endoscope is retracted from the box and when the apparatus is being set up for the next task. This is indicated by the break time periods in the timeline. The software can work both with live videos and recorded videos. Here we show an example of the results of the AI software on a test video. We emphasize that this video was not used for training the system, so it represents the performance on a novel video never seen before by the system. We have actually trained several different AI models, and the best performing one is indicated with the arrow. The context label is used to indicate no task being performed. As you can see, as we move to different parts in the video, the system is able to correctly determine the task being performed automatically, using only the video as input. In this slide, we illustrate what is under the hood. Firstly, the video is automatically divided into small clips of a few seconds. Next, all images in a clip are processed by a convolutional neural network, or CNN, which is a machine learning model with artificial neurons assembled in a layered structure. The CNN has been trained to recognize tasks from a large database of training clips beforehand. The output of the CNN is a predictive score for each task, with a higher score indicating more certainty. It also outputs a score for the no task or context stage, occurring when a user is not completing a task. In a second step, the predictions from each clip are combined to make a final prediction. We exploit the fact that tasks are normally performed in a specific order, for example, clipping before cannulation. This ordering allows us to achieve better robustness compared to using only the clip predictions from the CNN. In particular, it helps significantly when the endoscope does not have a clear view of the apparatus. To evaluate the performance of the AI system, we conducted a user study to answer whether AI task recognition has similar performance as a trained human rater. We evaluated with a dataset of 20 videos of flexible endoscopy trainees of intermediate level, recorded at the ESU Strasbourg. For each video and each task, a trained human rater assessed the task duration, which was compared to the AI predictions. We computed absolute error in seconds and relative error as a percentage of the task duration. Summary statistics of absolute error for each task are shown in the left figure using box and whisker plots. These show median error with a red central line, the 25 to 75 percentile range with boxes, and mean error with circles. Whiskers show extreme points and outliers are shown with plus marks. In terms of absolute error, the median across all tasks and all videos is below 10 seconds, and the corresponding median relative error is always below 5%. The mean errors are also low and below 5% in relative error for all tasks. We notice a few outliers, noticeably for peg transfer in retroflexion and snaring. In those cases, there was some ambiguity for when exactly preparation finished and the task started. Nevertheless, there were only 3 instances of tasks with relative error above 10%. 97.5% of all tasks had a relative error below 10%, which is a very strong preliminary result. We have demonstrated for the first time that AI can automatically recognize tasks being performed in a flexible endoscopy video. Furthermore, this can be achieved with remarkably high accuracy. We have 3 main objectives for future work. The first is to automatically recognize if errors are performed during a task, such as incorrectly placed pegs. We have already started work on this, as shown in the video. Here, another AI model has been trained to recognize only correctly transferred pegs. Next, once the machine can recognize all task errors, we have completed automation, and we can begin multi-center testing and start performance analytics across users and centers. Finally, we will investigate if the AI system can be considered for high-stakes assessment. That concludes the presentation, and thank you very much for your time.